Hello everyone, I am back with another video. Today I have developed another tool that will explain two important concepts in data analytics. So the two important concepts are pre-processing and augmentation. So here I am going to talk about pre-processing and augmentation in two different data types. So one of the data type is a text data, other one is a audio data. So in the text, the pre-processing is very important to keep the data consistent so that the data can be used across different applications such as either we can do text analytics or we can do any predictive models on that. So pre-processing is one of the important steps in a text data. So in under the pre-processing, so what are all the things that we'll be able to do on a text is we will be able to tokenize the text. We will convert the text into a lowercase. We can remove the punctuation symbols in the text. We can remove the stop words. We can use stemming and lemmatization. So stemming and lemmatization are nothing but two concepts in the text processing that will bring that particular word into its root form. For example, mm, liked, there is a word liked, right? The root form of the word liked is nothing but like. So stemming and lemmatization is going to bring the word back to its root form and remove emojis. So there will be certain symbols in the reviews whenever the user writes it. We wanted to remove such kind of symbols because that will not make sense to our application. So, but why do we have to do all this pre-processing to the our textual data? So whenever we get a raw text data, so most of the words or most of the text in that particular corpus will not be useful to us to perform any statistical analysis or either doing a predictive analysis. So that is why we convert the text by applying the pre-processing techniques. So which I'll be demonstrating one by one. So next, why do we have to do augmentation? So augmentation is nothing but creating a synthetic data. So in case we have a data set with us, but our data set lacks some kind of a variation. So there is not much variation, or our data set is like biased towards one certain class. There is a class imbalance. Then we can use this augmentation technique to introduce a variation in our data set. Also, we can use augmentation to upscale certain upscale certain classes which are very low in number, and we can also overcome the class imbalance in that way. So let's get to the demo. I will show a working of each and every technique one by one. So right now I will enter a raw text here which I have copied from Amazon review by a user. So let me load the text. So the user says couldn't rate it 5 star because, by the way, this review is for a smartwatch. Couldn't rate it 5 star because I haven't been able to download more faces to it. The health app on my watch doesn't have the face change tab updated as on so and so date, and he is expecting a update for that particular watch. And he also says if the faces can be added, this is a great buy. Generally, we take this kind of a texts, and generally a lot of models are created to classify whether this text is basically a positive review or a negative review. So in that case, the first step is to do some pre-processing here. So I have an option called default. When I do default, all these particular pre-processing techniques are going to get applied. So let me show you what is tokenization. Tokenization is nothing but breaking down each and every word into a numerical form, breaking down each and every text into a word form, and then we assign a unique number to that particular word. So basically, why this is done, because our models cannot understand the text directly. So in order to convert the text to numbers, we use something called as a tokenization. So when I click on pre-processing button, we can see that couldn't is assigned with the number called 99, and the rate is assigned with 39, so and so. So convert it into lowercase. We convert every word into a lowercase because it'll be consistent across the data, and all the data will carry the same meaning. So now you see all the particular words in this particular paragraph are converted into a lowercase, removing the punctuation. So when I remove the punctuations, you see the full stop, the date format, separator, brackets, everything is removed. Removing the stop words. So stop words are nothing but, in data analytics there are certain words which are not necessary. It doesn't carry any meaning. So you see this, many of this words are removed. So this is one way to reduce the corpus size. Stemming and lemmatization. As I told you earlier, you see the words are all reduced to its root form. You see the changed here, right? The change is getting changed to change here. So again, these are like bringing back the root words to a root form. And since we don't have any emojis here, I'll leave it that way. And when I click on default, all the techniques, pre-processing techniques that I showed you is going to get applied. You see, now the text is like completely pre-processed and we have written only the useful information here. So what is augmentation now? Augmentation is like, as I told earlier, it is like basically creating a synthetic data. We are going to create another data which is similar to this data but looks something different. So let me try a first augmentation technique called as a synonym replacement. You see here, it is like logically replacing certain words with this synonyms. Like couldn't place a fin commencement have been capable download brass wellness app watch does not boldness very check update new mile update hyperkinetic syndrome modern check watch outbrand bribe. So this is basically replaced with certain synonyms. Like when I click again, it is going to change. So this is how we can increase the number of data sets in our data whenever like we are having very low in numbers or something like this. So other one is nothing but a random swapping. When we do a random swapping, the words in that particular sentence would be swapped here and there randomly, so that like it will not have any meaningful word to us, but for to the machine it would make sense. So this is with respect to the text processing. So I will switch to another form of data that is like basically audio. So audio is nothing but the sound data. So sound data we generally capture from either microphone or any stethoscope or any other sound recording devices. So right now, the same pre-processing and augmentation applies same. The concept is same for audio data as well. But here we have some other techniques to pre-process the audio file, and we have a different augmentation techniques to improve the audio data set. For audio data set, we do something called as a normalizing. So normalizing is nothing but a sound is nothing but a amplitude, variation of amplitude. So the normalization brings all the all the different sound tracks in a particular audio file into a same level. Like for example, normalization would bring in a tabular data, any numerical data, it can be bringing it to 0 to 1. So in the same way, the amplitude of a sound data can also be brought into a certain threshold across all the channels, sound channels in a particular audio file. So that is what a normalization does. Noise reduction. So whenever we are recording audio, there will be a background noise or other environmental noise introduced to the audio file. So basically, noise reduction is to eliminate all such noises that are getting added to our audio file. Resampling. So basically, whenever we record audio, we convert it into digital form by sampling it. When we do a digital sampling, we take that particular frequency of that data and we try to sample number of samples in a particular second. So as the number of samples increases, we try to capture more number of data from the audio file, and when the number of sample reduces, we capture less number of data. So whenever we try to the samplings are very helpful in like bringing all those the soundtracks into a same scale. And when we try to mix up those particular sound channels, or when we try to process those particular different audio into a single audio or something, it is very helpful. The sampling, when they are all when all the sounds are like audio files are sampled into a single the sampling rate, then it is very easy to operate on the audio files. So these are the pre-processing techniques that I'll be showing in an audio for a audio file. And augmentation for audio file will be introducing a random noise. Like we will ourselves introduce a random noise to our data, so that it will become another variation of our original audio file. time stretching. So we can stretch the time. Audio is nothing but the amplitude versus time, right? So when we are stretching the time, basically what we try to do is like we vary the audio quality over the I mean we vary the audio over the time, and we create a different data. Like basically like stretching the time for a longer duration, it will create a something very slow talking, and that's how we can take a audio file and we increase the time stretching, video time stretching, and we create another new audio file out of it. And a pitch shifting. So pitch shifting is nothing but we vary the tone in the particular audio file. Whether we do a low tone or increase a tone, so that is going to create another new form of an audio. Like for example, we take a normal audio. This is my normal audio. When I do a low pitching, my voice changes like this, and when I do a high pitching, my voice changes like this. You get it right. So that is one that is called as a pitch shifting. So changing in the speed, like you again, it is kind of similar to time stretching. So changing in the speed, like whether you can do a slow audio or we can do a very fast audio, like you play it in 2x, right? The YouTube plays it in 2x. So such kind of things are like one of the augmentation technique where you pass in the original file and you try to create a new file with this particular technique. So let's get to the demo. I upload a audio file here, so I'll be able to listen, but you may not be able to listen here. So I have given a control to do the playback, but I have represented the audio in terms of a graph. So this is the visual representation of the audio. It is called as a oscillogram. So you see this is a time axis and this is the amplitude axis. So basically this is a visualization of that particular sound, whatever I uploaded. A spectrogram. So here I am plotting the MFCC spectrogram. So it is nothing but the male frequency coefficients. So this is one of the concept in audio that is going to capture important features which are like human understandable feature, like how we recognize an audio. Similarly, the system also MFCC features are nothing but those features also understand the same way that the human understands the sound. So that is what we represent as a graph here. So this is the spectrum, MFCC spectrum of the audio file that I have uploaded, and this is the basically amplitude versus time of the audio file that I have uploaded. So what I will do is like when I'll show you the normalization. So right now it is normalized. So you see the audio file, whatever we uploaded, is being normalized from 0 to 1. The amplitude, the maximum amplitude here is going to zero point 0.6, right? Here we have like reduced it to, scaled it to 1. So this is how the normalization works. So this is one of the pre-processing steps. So I'll do this noise reduction here. So you can clearly see the difference between the input file and the output file. So you see, we can see this like there are like unwanted lot of unwanted noises that are removed from our audio file. So this is one of the way that we pre-process the audio file and remove the noises. So let's move on to the augmentation. So a random noise is again going to add the noise for the input image. So let us do this time stretching and then see it. So you see, when we do a time stretch, you can see a difference in this particular space. Like we have in terms of 0 to 5 seconds, right? We have introduced like we have moved this particular 5 seconds data to 2.5 in between 2.5 and 5. So basically we are shrink the particular audio file and we have created a new audio file here. So this is how we can augment a given audio file. So these are the important concepts in data science. So pre-processing and augmentation are the two important steps that we do once we load the data and before we do send the data to any particular model for doing any particular predictions or classifications or any sort of the other modeling operations. So yeah, that's about this particular application. Thank you.